Hello guys, in this problem we are required to find the critical points and to determine whether the function has a local min or local max. So the first thing that we need to do here, or step number one, we need to first find f prime of x. So f prime of x is equals to 2x plus 2. Then the second step here is to say f prime of x is equals to 0, and then we're going to solve for x, so 2x plus 2 equals to 0. And then from here I'll call it step number 3, where we solve for x. Then 2, we take 2 as a common factor, then we're left with x plus 1 equals to 0. And then from here we divide both sides by 2. Divide both sides by 2, cancel. You have x plus 1 equals to 0. Therefore, you have your value of x is equals to minus 1. When you take out the plus 1 to the other side, it becomes minus 1. So this value of x that we got here, this x equals to 1, it's our critical point, right? Critical point. So from this point onwards, what you need to do is to draw a number line like this, and then you have your minus 1 here. You have, of course, number line start from negative infinity to positive infinity, right? So what do we need to do? Let's substitute a number between minus 1, minus infinity, between minus infinity and 1. What would be that number? Maybe minus 2, right? Let's substitute minus 2 on the first derivative, which is this one here. So if you substitute minus 2 there, you're gonna have a negative answer. So if you substitute minus 2, it's gonna be 2 minus 2 plus 2 equals 2. Okay, maybe let me write down here. So this is equals to minus 4 plus 2, which is equals to minus 2. So we're interested in the sign. So this is a negative sign. So we have a negative sign. And then let's substitute a number between minus 1 and positive infinity. We could substitute like a 0 onto the first derivative. So this is 2 times 0 plus 2, which is equals to positive 2. So the sign here is positive. So now we know that this sign is coming down, it's decreasing because it's negative, and then from minus 1 to positive infinity, it's increasing, right? So in this case, we obviously have a local, we have a local minimum. We have a local minimum at x is equals to minus 1, right? And already you could see from the function itself, what is it? Um, the coefficient, the coefficient of x is positive, right? Remember, if you have a coefficient of positive greater than 0, you have a smiley graph, and then you have a minimum. And then if you have x is less than 0, where you have a frown, and then you would have a maximum. So remember these conditions of a parabolic function or a cubic function. So that's why, right? That's something that you need to remember there. So we have a local minimum at x is equals to minus 1. So in order to find the actual point of the local minimum, we need to substitute our x equals to minus 1 onto the original equation. Let's rewrite the original equation, which was given to be x is equals to x squared plus 2x minus 4. Then we have f of minus 1, it's equals to minus 1 all squared plus 2 times minus 1 minus 4. Then we can simply get this to 1 minus 2 minus 4, right? And then, okay, what is the answer here? Minus 6. Minus 6 plus 1, it's minus 5, right? So that's f of minus 1, right? So that's your so our point of local minimum in our graph, it will be this point. And then this point is also considered the turning point, turning point turning point, sometimes also called the vertex. So that's where you have your local minimum, in this case, right? And the x value of this part or this one is called the critical point, right? The critical point. So that's what thing we notice here. So yeah, that's how you solve such a question where they require to find the local mean, local max. You first find the first derivative, equate it to 0, solve for x, and then um, after that you get then you need to draw a number line, test whether you have a local min or local max. Then that's how you approach it. Thank you guys. Don't forget to like, subscribe, and share the video with your friends. Cheers.